Hi friends, this is Naresh. This is my ninth lecture on design of bearings. In this session, I am going to explain about rolling contact bearings. Okay, I will explain in this session different types of contact bearings, rolling contact bearings, that is ball bearings and roller bearings. I will discuss in this session. Rolling contact bearings. These are example for rolling contact bearings. This is another example of a rolling contact bearing. In rolling contact bearings shown in here, the steel balls. Here, these are the steel balls or steel rollers. Okay, these are balls. These are rollers. Okay, the steel balls or steel rollers are interposed between the moving and fixed elements. Okay, interposed between the moving and fixed elements. This is a moving, this is a moving element, this is a fixed element. Okay, the balls offer rolling friction at 2 points for each ball or roller. Okay, the balls or rollers offer rolling friction. Okay, here the balls or rollers offer rolling friction at 2 points. Okay, 2 points for each ball or roller. Okay, here the following are the two types of rolling contact bearings. That is, first one is ball bearings. These are the example for ball bearings, and the second one is roller bearings. This is the example for roller bearings. Okay, here these both are in rolling contact. Okay, here this is a moving element. This one also moving element. Okay, this is a fixed element. Okay, here the balls are used in ball bearings. Okay, here this one is a fixed element. These are moving elements, and these are rolling elements, and this one is a moving element. Okay, so here the rollers are used in roller bearings. Okay, balls are used in ball bearings and rollers are used in roller bearings. Okay, here the rollers are in maybe cylindrical shape or spherical shape. Okay, here the balls are in sphere shape. Okay, so these balls are rollers are used to use it to minimize the friction. Okay, these balls or rollers are used to minimize the friction between the rolling element and fixed element. Okay, rolling elements. Okay, here in ball bearings, these balls are used. So these balls are called rolling elements. Okay, because these balls are rolls. Okay, now in roller bearings, these rollers or cylinders are used as a rolling elements. Okay, these are the rolling elements for roller bearings. These are the rolling elements for ball bearings. Okay, here these balls are in sphere shape. Here these rollers are cylinders in cylindrical shape or in spherical shape. Okay, these are the different shapes of rollers or cylinders. Okay, now I am going to explain about construction of rolling contact bearings. These are the main elements consisting of rolling contact bearings. Okay, yeah, this one is a seal. Seal may be rubber material or a plastic material to close the lubricant. Okay, it acts. This seal act as a sealant. Okay, now this one also a seal. Okay, both sides we are using two seals. Okay, and this one is outer race. Okay, this is a fixed element, it is not moving. Okay, this is a fixed element. So this one is a outer race. It has a inner groove. Here this you can observe here, there is a inner groove. Okay, to support these balls. Okay, to support moving elements, we are making grooves. Okay, this is the outer race. Now these balls are called rolling elements. Okay, here we are using balls or rollers as a rolling elements, and this one is a retainer. Okay, retainer or cage. Okay, this one is a retainer or a cage. Okay, cage or retainer are used to to hold the used to hold these balls or rollers. Now this one is inner race. This inner race also having a groove. Okay, external groove. This is external groove. This is internal groove. Okay, outer race having internal groove. Inner race having external groove. Okay, this groove also used to support the balls or rolling elements. Okay, so these all are the elements considered in rolling contact bearings. Okay, now I am explain about rolling contact bearings in briefly. Okay, the ball and roller bearings consist of an inner race which is mounted, or this is the inner race. This is a ball bearing example, this is a roller bearing example. This outside one is inner race. This inner race which is mounted on the shaft. Okay, here we are placing a shaft. Okay, so this inner race mounted on the shaft or a journal. Okay, and this one and this one is called outer race. Outer race which is carried by housing or casing. Okay, in between the inner race and in between the inner race and outer race, there are balls or rollers. Okay, there are balls or rollers as shown here. A number of balls or rollers, the number of balls or rollers are used, and these are held at proper distances. Okay, by using retainers, so that they don't touch each other. Okay, the retainers are thin strips. Okay, these are the retainers. The retainers are thin strips and is usually in two parts, which are assembled after the balls have been properly spaced. Okay, the ball bearings are used for light bearings. These ball bearings are used for light loads, and roller bearings are used for heavier loads, because the rolling contact of balls are very less as compared to contact area of rollers. Okay, the roller bearings, these roller bearings having high contact. Okay, high contact area, therefore it carries heavy loads, whereas balls having having less contact area. That's why these balls carries less load. Okay, so the ball bearings are used, therefore the ball bearings are used for light loads, and the roller bearings are used for heavier loads. Okay, the rolling contact bearings, depending upon the load to be carried, are classified as radial bearings and thrust bearings. Okay. Now this is the cross-sectional shape of a ball bearing. Okay. This is a half-sectional view. Okay. Here this is the hole for shaft. Okay. So this one is called inner race, this one is called outer race. Okay, here you can observe here a small grooves. Here grooves are there, small grooves used for holding the balls. Okay, now I am going to explain about advantages and disadvantages of rolling contact bearings over sliding contact bearings. Okay, here sliding contact bearings also called journal bearings. Okay, so the following are some advantages and disadvantages of rolling contact bearings over journal bearings. Okay, advantages of rolling contact bearings over journal bearings. First one is low starting and running friction except at very high speeds. Okay, here these ball bearings or roller bearings having low starting friction and low running friction at low speeds. Okay, and the ball bearings or roller bearings having ability to withstand momentary shock loads. Okay, so it can maintain or it can resist shock loads or fatigue loads. These ball bearings or roller bearings are having high accuracy. Okay, high accuracy of alignment, shaft alignment. Okay, so these ball bearings and roller bearings are having high accuracy of shaft alignment. That's why these ball bearings or roller bearings are widely used in our mechanical machineries. And the cost of ball bearings and roller bearings are also less as compared to journal bearings. And the construction of these roller bearings and ball bearings are also very very easy to construct. That's why the cost of ball bearings are also very low cost. Here for ball bearings and roller bearings, there is no need of lubrication. Okay, there is no need of lubrication while in service. Okay, once you are putting a lubrication in inside the bearing, then it will run smoothly a long time. Now these are small overall dimensions. That means the size of roller bearings and ball bearings are very compact as compared to journal bearings. Okay, and the service life of these ball bearings and roller bearings are also very high as compared to other bearings. Okay, and the reliability of service. And seventh one is easy to mount and erect. Okay, the ball bearings and roller bearings are easy to assemble and disassemble. Okay, that means easy to mount and easy to erect. And the ball bearings and roller bearings are cleanliness. Okay, that means the construction of these ball bearings and roller bearings are good and nice, and there is no need of external lubrication. Okay, that's why there is no dust particles or mud or oil. There is no mud or oil on surface of the bearings. Okay, you can maintain very clean and neat. Now I am going to explain about disadvantages of rolling contact bearings over journal bearings. uh, Here the main disadvantage of these ball bearings or roller bearings are more noise. more noisy at very high speeds. Okay, this is the main disadvantage of roller bearings. Okay, so these rolling contact bearings having more noise at very high speeds, and these rolling contact bearings having low resistance to shock loads. Okay, these ball bearings or roller bearings having uh, low resistance to resist the shock loads. Okay, and these rolling contact bearings also having high initial cost, and the design of bearing housing is complicated. Okay, the design bearing housing means for holding the balls and rollers, we have to make a groove. Okay, you have to make a inner race and outer race for holding the balls, or rollers. So for making of that inner race and outer race, it takes so much of time and time consuming process. That's why the cost of these rolling contact bearings are very high as compared to journal bearings. Okay, so these are the advantages and disadvantages of rolling contact bearings over journal bearings. Okay, now I am going to explain about different types of rolling contact bearings. Yeah, the rolling contact bearings are broadly classified into ball bearings and roller bearings. In ball bearings, we are using balls, whereas in roller bearings, we are using rollers. Okay, here balls and rollers are rolling elements. Okay, now I am going to explain about types of ball bearings. Okay, now the following are the various types of radial ball bearings. Here, these ball bearings these are the different types of ball bearings. First one is a single row deep groove ball bearing, and double row deep groove ball bearing. This is a double row deep groove ball bearing. This is single row deep groove ball bearing. In single row deep groove ball bearing, we are using only single row of balls. Okay, here there is no. Okay, in single row deep groove ball bearing, we are using one row of balls. In double row ball bearings, we are using two rows of balls. Okay, these balls are having here in single row ball bearing. The contact area for these balls are very less as compared to double row ball bearings. So these single row ball bearings having having less capacity to resist the shock loads or impact loads, whereas these double row ball bearings having higher contact area as compared to single row deep groove ball bearing. That's why these double row deep groove ball bearings are used for resist the high loads. Now this one is a filling notch ball bearing. Here the design, here you can observe here. Here we are providing extra filling notch. Okay, for providing more amount of lubricant or more number of balls. Okay, so here you can observe here in a deep groove ball bearing, there is no extra notch. Okay, but here we are providing extra filling notch. Okay, to provide extra lubrication. Okay, and this one is angular contact ball bearing. In this one, uh, here we are using angular shape grooves. Okay, and this one is a self aligned ball bearing. In this In this self-aligned ball bearing, we are arranging a spherical shape of a groove for self-aligning. Okay, self-aligning of balls at the time of loading, at the time of thrust loads or radial loads. Okay, these five types of ball bearings are used for radial loads, for carrying the radial loads, and thrust ball bearings are used for carrying the thrust loads. Okay, now single row deep groove ball bearing. Okay, this is the figure for a single row deep groove ball bearing. Here, a this one ball is used as a rolling element. Okay, for holding this ball, we are making a inner race and outer race for holding these balls, and this one is a retainer. Okay, this is a retainer to hold these balls in separate distance. Okay, a single rod deep groove ball bearing is shown here, and during assembly of this bearing the races are offset. Okay, the races are offset and the maximum number of balls are placed between the races. Okay, this one you can observe here, this is inner race and this one is the outer race. Okay, during assembly of this bearing, the races are offset and the maximum number of balls, these balls are placed between the inner race and outer race. Okay, and the races are then centered and the balls are symmetrically located by the use of retainer. Okay, this one is the retainer or cage. Okay, the deep groove ball bearings are used due to their high load carrying capacity and sustainability for high running speeds. Okay, the load carrying capacity of a ball bearing is related to size and number of the balls. Okay, so the capacity of the load carrying capacity of ball bearings depends upon the number of balls used in bearing. Okay, and also it depends upon the size of the balls. Okay, now double row ball bearings. In double row ball bearings we are using two number of rows. Okay, here for in construction of a double row ball bearing we are using two symmetrical inner race and outer race. Okay, the double row ball bearing is shown here. These bearings may be made with radial or angular contact between the balls and races. Okay, the double row bearing is appreciably narrower than two single row bearings. Okay, the load capacity of such bearings is slightly less than twice that of a single row bearing. Now this is a filling notch ball bearing. A filling notch bearing is shown in here. These bearings have notches. These are called notches. Notches in the inner and outer races, which permit more balls to be inserted than in a deep groove ball bearings. Okay, and the notches don't extend to the bottom of the raceway, and therefore the balls inserted through the notches must be forced in position. Okay, since this type of bearing contains large number of balls than a corresponding unnatural one. Okay, therefore it has a larger bearing load capacity. Okay, so these type of filling notch ball bearings having higher capacity than the single row deep groove ball bearing. Okay, because here we are using filling notch, so therefore we are using larger balls. Okay, this one is the angular contact ball bearings. Here the shape of this inner race and outer race is very different than other ball bearings. Okay, an angular contact bearing is shown here. These bearings have one side of the outer race cut away. Okay, these bearings have one side of the outer race. This is outer race. One side of the outer race cut away to permit the insertion of more balls. Okay, more balls than in a deep groove ball bearing, but without having a notch cut into both races. Okay, this permits the bearing to carry a relatively large axial load in one direction while also carrying a relative large radial load. Okay, the angular contact bearings are usually used in a pace so that thrust loads may be carried in either direction. Okay, these are the examples for self-aligning ball bearings. A self-aligning ball bearings here shown here. These bearings permits shaft deflections within 2 to 3 degrees. Okay, it may be noted that normal clearance in ball bearing are too small to accommodate any appreciable misalignment of the shaft relative to the housing. Okay, if the unit is assembled with the shaft misalignment present, then the bearing will be subjected to a load that may be in excess of the design value, and premature failure may occur. Okay, so there are two types of self-aligning ball bearings are there. First one is externally self-aligned ball bearings, and second one is internally self-aligned ball bearings. Okay, in an externally self-aligned bearings, the outside diameter of the outer race is ground to a spherical shape. Here you can observe here, this is a spherical shape. Okay, so spherical shape which fits in a mating spherical surface in a housing. Okay, in case of internally self-aligning bearings, the inner surface of the outer race is ground to a spherical surface. Consequently, the outer race may be displaced through a small angle without interfering with the normal operation of the bearing. The internally self-aligning ball bearing is interchangeable with other ball bearings. Okay, so these are the arrangement of self-aligning ball bearings. Okay, this is a retainer. Okay, now these are the examples for thrust ball bearings. Thrust ball bearings are used for carrying the thrust loads. Okay, here the loads are acting along the axis of the shaft. Okay, in in, in whereas single row deep groove ball bearing, double row deep groove ball bearing, self-aligned ball bearings, uh, those are used for carrying the radial loads. But these thrust ball bearings are used for carrying the thrust loads. Okay, uh, here the loads are acting along the axis of the shaft. Okay, that's why these are very difficult to carry the load. So the thrust ball bearings are used for carry thrust loads exclusively and at speeds below 2000 rpm. Okay, at high speeds centrifugal force causes the balls to be forced out of the races. Okay, therefore, at high speeds, it is recommended that angular contact ball bearings should be used in place of thrust ball bearings. A thrust ball bearing may be a single direction flat face as shown here. Okay, and a double direction with the flat face as shown here. Okay, Now these are the examples for different types of roller bearings. Okay, so this one is a cylindrical roller bearings. This one is a spherical roller bearings. This one is a needle roller bearings. This one is a tapered roller bearings. Okay, here the main difference is inner race and outer race design. Okay, and the shape of the shape of this roller is in cylindrical shape. Okay, that means there is no taper in shape, but in spherical roller bearings the rolling element is in a shape of spherical shape. Okay, so you can observe here the shape is here like spherical shape. Okay, here in needle roller bearings the diameter of the roller is very less, very small as compared to other roller bearings. Okay, in tapered roller bearings, the shape of the roller in tapered cross section. Okay, so these are the different types of rolling or roller bearings. Okay, now first one is cylindrical roller bearings. A cylindrical roller bearing is shown here. Here these are the rolling elements. Here we are using rollers for rolling elements, and this one is outer race. Outer race is a fixed element, and this one is a inner race. Okay, here we are using a groove for inner race. Okay, these bearings have short rollers guided in a case. Okay, this one is a case or retainer. Okay, to hold these rollers we are using case. These bearings are relatively rigid against radial motion and have the lowest coefficient of friction of any form of heavy duty rolling contact bearings. So such type of bearings are used in high speed service. Okay, now second one is spherical roller bearings. Here a spherical roller bearing is shown here. Okay, these bearings are self-aligned bearings. Okay, these are also called self-aligned roller bearings. Okay, spherical roller bearings are self-aligned roller bearings. The self-aligned feature is achieved by grinding one of the races in the form of a spear. Okay, here you can observe here the outer race having a spherical shape groove. Okay, so you can observe here the shape of the rolling element also in a spherical shape. Okay, you can observe the outer shape of this rolling element. Okay, this is in spherical shape. Okay, these spherical rollers are used in spherical roller bearings. Okay, these bearings can normally tolerate angular misalignment and when used with a double row of rollers. Okay, these can carry thrust loads in either direction. Okay, now the third one is needle roller bearings. A needle roller bearings is shown here. These bearings are relatively slender and completely fill the space. Okay, completely fill the space so that neither a cage nor a retainer is needed. Okay, these bearings are used when heavy loads are to be carried with an auxiliary motion. Example, piston pin bearings in heavy duty diesel engines where the reversal of motion tends to keep the rollers in correct alignment. Okay, these small rollers are called needle rollers. Okay, so here we are using more number of rollers. Okay, for carrying the heavy loads. Now the last one is tapered roller bearings. Here the tapered roller bearings we are using taper rollers. Okay, the shape of these rollers in a taper section. Okay, the rollers and raceways of these bearings are truncated cones. Okay, whose elements intersect at a common point. Okay, such type of bearings can carry both radial and thrust loads. Okay, these taper roller bearings also can carry the radial loads as well as thrust loads. These bearings are available in various combinations as double row bearings and with different cone angles for use with different relative magnitudes of radial and thrust loads. Now this is the application of taper roller bearings. This is a double row taper roller bearing. This is the example of double row taper roller bearing, and this is a single row cylindrical roller bearing. This one is a single row cylindrical roller bearing. This one is a double row tapered roller bearing. Okay, this is the arrangement of a shaft. Okay, so here for supporting this shaft we are using two bearings. Okay, for this one is cylindrical roller bearing, single row cylindrical roller bearing. This one is a double row tapered roller bearing. Okay, this is the example of single row taper roller bearing. Okay, but here we are using a double row taper roller bearing. Now coming to the another topic, that is a dynamic equivalent load for rolling contact bearings. Okay, what is the dynamic equivalent load for rolling contact bearings? The dynamic equivalent load may be defined as the constant stationary radial load or axial load. Okay, radial load in case of a radial ball or roller bearings, axial load in case of thrust roller bearings, which if applied to bearing with rotating inner ring and stationary outer ring, okay, would give the same life as that which the bearing will attain under the actual conditions of the load and rotation. Under a combined constant radial load WR, here WR is the radial load and the constant axial or thrust load WA is given by a W equal to X V WR plus Y WA. Here W is the equivalent load. Okay, dynamic equivalent load. W is the dynamic equivalent load and WR is the radial load and WA is the axial load. Okay, whereas capital V is the rotation factor. V is a rotation factor. The value of rotation factor for all type of bearings, when the inner race is rotating, then V equal to 1. You have to consider V equal to 1 for all type of bearings when inner race is rotating. Whereas V equal to 1 for self-aligned ball bearings when inner race is stationary. Okay, so here X and Y, the values of X and Y are taking from data handbook. Okay, these X and Y values are depends upon the type of bearing. Okay, the values of radial, here X is the radial load factor, Y is the axial load or thrust load factor. Okay, X is called radial load factor, Y is the thrust load factor. Okay, these are taken from data handbook. These are the data handbook values and the values of X and Y for dynamically loaded bearings. Here you can observe here, these are the types of bearings. These are the specification of the bearings and these are the X and Y values, radial load factor and axial load factors. Here this is the load ratio, that is axial load by radial load is called load ratio. Okay, when load ratio is less than or equal to E, we are using these values. When load ratio is greater than E, then you have to consider these values. Here E is the load ratio value. Okay, by using these load ratio values, you have to consider X and Y values. Okay, for deep groove ball bearings, we are using these values, and for angular contact ball bearings, we are using these values, and self-aligned ball bearings, we are using these values. Okay, here the different types are there. Series for bores: 10 to 20 mm, 25 to 30 mm, 40 to 45 mm, 50 to 65 mm. Okay, these are the different bore series. Okay, these are the medium series. And here the spherical roller bearings are also there. Tapered roller bearings are also there. Okay, these are the some examples for rolling contact bearings. Okay, in next class, that is in next class, I will explain about some dynamic loading, equivalent dynamic loading problems. Okay, tomorrow I will discuss about those problems. Okay.